Right, by means of integration we want to get the area of this curve over here. Y equals x squared plus 7x. And because there's a positive coefficient in front of the x squared, it's going to be like a happy face like this. If it was minus x squared, it would be a sad face, okay, but we know it's this type of shape, and we need to determine 2 or 3 points of interest in order to sketch it, and the first point then will be the minimum point, the point at the very bottom, and we do that using differentiation. We get the first derivative there of y, so dy dx equals 2x plus 7. And now that we have this first derivative, we set that, we solve that, we equate that to 0 and solve it. So we go 2x plus 7 equals 0. We solve this for x, so subtracting 7 from both sides, I get 2x equals minus 7. Dividing both sides by 2, I get x equals minus 7 over 2, which is the same as minus 3.5. And that there is the x part of our turning point. To get the y part, we go back to our original y function and we put in minus 3.5 for x. So minus 3.5 squared plus 7 times minus 3.5. And we figure out what that comes to using the calculator. And I have it done here already. And I get minus 12.25. Minus 12.25. So that means our turning point has the coordinates minus 3.5 and minus 12.25. So that is our turning point sorted out. Now, the next points we need to figure out are where our graph cuts the x-axis. These 2 points. And them points are known as roots. So to get the roots, we solve this guy here, x squared plus 7x. So to solve that, we can set it x squared plus 7x equal to 0. We're going to solve that now, so we can factor out the x here. X times x plus 7 equals 0. So now in this type of setup we can say that x equals 0 or x plus 7 equals 0. So x equals 0 or x equals minus 7. So these are our 2 values of x where our graph cuts the x-axis. So because they're on the x-axis, they're going to naturally have a y is 0, right? So their y value will be 0. We've set y to 0 here anyway. X squared plus 7x equals 0. So the coordinates will be 0, 0, which is the origin, happens to be the origin, and minus 7, 0. So these 2 guys here are known as our roots. And down here, this one here is our minimum point. Okay, so sketch the graph. Well, that point there, here, that's 0, 0. Notice a pokey wee sketch, but this point here is minus 3.5, minus 12.25. Right, and this guy here is minus 7, 0. Now you see that 0, 0, that's the origin, so we know that the y-axis runs up there. So you can put that in if you wanted. Right, that's the y-axis. And that's a sketch of our curve. I've already done it here, I can show it to you on Desmos. And that's it there on Desmos, which will run on any browser. You can do that on your phone. Now going back, what we've done our sketch. Now we need our determination of sections. Well, we're going from x equals minus 8. So x equals minus 8 will be out here, and x equals minus 3 will be just above the minimum point here. So continuing on our graph, it'll rise up like so. So our sections, this is proven to be a bit small, we can redraw it maybe. This is one section here, from x equals minus 8 into x equals minus 7. That's where the graph is positive, it's above the x-axis. And then as x gets more positive, from x equals minus 7 to x equals minus 3, we're interested in this bit of the graph here. Okay, so the area under the curve is going to be the sum of these two areas. So we're going to have to integrate. Let's see now. We're going to have to integrate from x equals minus 8 in as far as x equals minus 3. Right, minus 3. Now our graph bottoms out at x equals minus 3 and it sweeps down like this, say, very roughly. So we'll be getting this area, and we'll be also getting this area. We'll have to do two integrations and add them together, because if we integrate the whole way between the minus 3 and minus 8, there'll be some cancelling out going on. We'll do that now in the next wee video.